Hello everyone. It's a great honor to present our work, Coaching a Teachable Student. In this work we propose CAT, a novel deep knowledge distillation framework, for effectively teaching a sensorimotor student agent to drive from the supervision of a privileged teacher agent. The method comprises 3 steps. We first design a high-capacity privileged agent that surpasses prior experts on CARLA. The agent is learned via imitation over a safety-aware bird's-eye view space. To address the differences in inputs between student and teacher networks, we leverage a transformer-based image-to-BEV space alignment module. The student can then benefit from extensive deep supervision over its internal features. To scaffold the difficult sensorimotor learning task, the student model is optimized via a student-paced coaching mechanism with various auxiliary supervision. Our method enables effective knowledge transfer between a privileged teacher and a sensorimotor student, resulting in a robust image-based behavior cloning agent, achieving state-of-the-art performance on CARLA. Now, we will dive into the details of our proposed CAT framework. To ease the challenging sensorimotor agent training task, recent approaches decompose the task into stages, by first training a privileged network with complete knowledge of the world, and distilling its knowledge into a less capable student network. However, current distillation methods for sensorimotor agents result in suboptimal driving behavior, due to inherent differences between the inputs, modeling capacity, and optimization processes of the 2 agents. In this work, we sought to develop a more effective knowledge distillation paradigm, for training a sensorimotor agent to drive from the supervision of a privileged teacher agent. To achieve this goal, our contributions are threefold: a stronger privileged agent, a teachable student via alignment module, and a student-paced coaching mechanism. Our objective is to train a goal-conditional sensorimotor agent, for mapping 3 RGB camera views, a categorical navigational command, and an intermediate noisy goal sampled from a GNSS, to future 2D waypoints, which are given to a lateral and longitudinal PID controller to generate the final action. Given a dataset comprising sensory and privileged observations, we optimize the loss functions defined over either final layer output, or over internal layers. Given the low performance of prior privileged agents, the teacher could benefit from more explicit safety-driven cues in the BEV. We propose to add 2 types of BEV channels, agent forecast, and entity attention. We utilize a kinematics model to predict future trajectories of traffic participants. We also encode an explicit attention channel to highlight potential future infractions. Our boosted teacher agent even outperforms the rule-based expert. Due to differing inputs and modeling capacities, it can be difficult to align the image-based student features and output with the BEV-based privileged teacher. Therefore, we proposed an internal image-to-BEV alignment module. Specifically, we first sample queries using a spatial parameterization of the BEV space, and process them with a self-attention module. Then, a deformable cross-attention module is applied to populate the student's BEV features. The residual blocks following the alignment module can consequently facilitate knowledge transfer, via direct distillation of the teacher's features. Our optimization objective for guiding this distillation process is a weighted sum over output distillation, feature distillation, and auxiliary tasks, including BEV segmentation and command prediction. To better consider the learning ability of the student, we gradually coach the student with a student-paced coaching mechanism. It adjusts the learning rate in a sample-selective manner, which aims to stabilize training by reducing the difficulty, when the student is unable to perform the optimal action. We present our closed-loop evaluation results on the longest 6 benchmark in CARLA. As illustrated in the table, CAT is able to achieve state-of-the-art performance among all prior agents, including LiDAR-based approaches. Moreover, we note that our final privileged BEV agent even outperforms the rule-based expert. We demonstrate the advantages of our proposed multi-layer feature distillation framework, through an ablation study. Unlike previous methods that only distill a single final fully connected layer, yielding minimal gains, our CAT with comprehensive feature distillation achieve an improvement in the driving score from 45.23% to 55.55%. Furthermore, the integration of multiple types of feature distillation losses, including chamfer distance, further contributes to improved performance. We also present the results of our open-loop evaluation on new scenes dataset, where our CAT framework demonstrates a 14.6% improvement in average displacement error, compared to an agent without distillation and coaching. Additionally, we observe a significant reduction in collision rates compared to the baseline approach. Here are some qualitative results. We demonstrate that our teacher agent with proposed knowledge distillation is able to guide the student agent in learning scene-relevant representations and attend to safety-critical entities. Here are more qualitative examples in video. In summary, we present CAT, a novel knowledge distillation method for effectively training a sensorimotor student agent, using the supervision from a privileged agent. We leverage an alignment module that enables extensive supervision from a BEV-based teacher, over the intermediate feature learning. To learn a more effective privileged teacher, we incorporate explicit safety-aware cues into the BEV space. Finally, we carefully account for inherent differences between the student and the teacher using a student-paced coaching mechanism, with various auxiliary supervision tasks. Thank you for watching.